7067. Which situation would require the highest power effect, and more power is needed to hover over tall setting to hover? A. Headed downwind in moderate wind speeds. B. Headed crosswind in moderate wind speeds. C. Over tall grass in zero wind conditions. The correct answer is C. Hovering over tall grass presents a challenging situation for a helicopter due to the increased ground effect and the potential for rotor blade tip interference with the tall grass. When hovering close to the ground, the rotor downwash is trapped and compressed by the surface, creating a cushion of air known as ground effect. This ground effect increases the efficiency of the rotor system, reducing the power required to maintain a hover. However, when hovering over tall grass, the rotor blades can come into contact with the grass, leading to increased drag and reducing the efficiency of the rotor system. As a result, more power is needed to overcome the increased drag and maintain a stable hover. In zero wind conditions, there are no additional forces from the wind that could affect the helicopter's stability or power requirements. Therefore, the main factor influencing the power requirement in this scenario is the increased drag caused by the tall grass. 6617-1. Can the tail rotor produce thrust to the left? A. No. Only thrust to the right can be produced, causing tail movement to the left. B. Yes, primarily so that hovering turns can be accomplished to the right. C. Yes, primarily to counteract drag of the transmission during autorotation. The correct answer is C. The tail rotor of a helicopter is responsible for generating thrust in the opposite direction of the main rotor torque to counteract the torque effect and maintain the helicopter's heading. While the primary purpose of the tail rotor is to produce thrust to the right, there are certain situations where it can also produce thrust to the left. During autorotation, which is a state where the main rotor is being driven solely by the upward flow of air through the rotor system rather than engine power, the transmission drag can cause the helicopter to yaw to the right. To counteract this yawing motion, the tail rotor can produce thrust to the left, helping to maintain heading control. The tail rotor's ability to produce thrust to the left in this scenario is primarily to counteract the drag of the transmission and maintain a balanced flight condition during autorotation. 6617-2. Feathering of rotor blades means the angular change of the blades during a cycle of revolution in order to A. Equalize lift on the opposite, retreating and advancing blade side of the disc. B. Equalize lift on upwind and downwind sides of the rotor disc. C. Counteract gyroscopic precession. The correct answer is A. Feathering of rotor blades refers to the process of changing the pitch angle of the blades during each revolution of the rotor. This adjustment of the blade pitch allows for the equalization of lift on the opposite sides of the rotor disc, specifically the retreating and advancing blade sides. In helicopter flight, the advancing blade, which is the blade moving in the same direction as the helicopter's forward flight, experiences higher airspeed and generates more lift compared to the retreating blade, which is moving against the direction of the helicopter's forward flight and experiences lower airspeed. By feathering the rotor blades, the pitch angle of the blades can be adjusted to ensure that the lift generated by each blade is balanced. This equalization of lift helps maintain the stability and control of the helicopter during forward flight. 6617-3. During a cycle of revolution of the main rotor system, movement of the cyclic control in a helicopter changes the angle of A. Attack of the blades individually. B. Attack of the blades between the root end and the tip. C. Incidence of the blades individually. The correct answer is B. The cyclic control in a helicopter allows the pilot to control the pitch angle of the rotor blades as they rotate around the rotor mast. When the pilot inputs a control movement on the cyclic, it causes the swash plate to tilt, which in turn changes the pitch angle of the blades. The movement of the cyclic control affects the angle of attack of the rotor blades between the root end and the tip. The angle of attack refers to the angle between the chord line of the blade, a line connecting the leading and trailing edges of the blade, and the oncoming airflow. By adjusting the angle of attack of the blades at different positions along their length, the cyclic control allows for the control of lift distribution during each revolution of the rotor. This helps in controlling the helicopter's attitude and direction of flight. 6617-4. The ability of a rotor blade to rotate about its spanwise axis is called A. Flapping, B. Feathering, C. Dragging or hunting. The correct answer is B. Feathering refers to the capability of a rotor blade to rotate about its spanwise axis. This rotational movement is crucial for controlling the pitch angle of the rotor blades during flight. In a helicopter, the rotor blades are attached to the rotor hub and rotate in a circular motion. Feathering allows the pilot to adjust the pitch angle of the blades individually as they rotate. By changing the pitch angle, the pilot can control the lift and thrust generated by the rotor system. Feathering is typically accomplished through the use of a swash plate mechanism, which allows for individual blade pitch control. This mechanism enables the pilot to adjust the angle of attack of each rotor blade as it rotates, which affects the lift and thrust produced. By varying the pitch angle of the rotor blades through feathering, the pilot can achieve different flight conditions. For example, increasing the pitch angle generates more lift, allowing the helicopter to climb. Decreasing the pitch angle reduces lift, facilitating descent or forward flight. Feathering also plays a crucial role in autorotation, a maneuver used in case of engine failure. During autorotation, the pilot adjusts the pitch angle of the rotor blades to enter a state where the airflow sustains rotor rotation and provides lift, allowing for a controlled descent and landing.